Okay, so I'm going to talk you through worksheet 7, which is the practical worksheet. Very briefly, I'm going to talk you through experiment 1. Through experiment 1. The reason for the brevity there being that you study this at Key Stage 4. This is simply the test for the halide ions, okay? And you add some, if you remember, silver nitrate, AgNO3, to either potassium chloride, potassium bromide, or potassium iodide. This is actually acidified, this silver nitrate, and you do need to know the reason for that. The reason is it removes any impurities, specifically any carbonate ions that might be present in the solution, and you do want to be specific in your answer. As and where you can. So, observations then, you should know for chloride ion, I always remember CW, BC and IY, and I remember that as CW as coursework, BC as in before Christ or AD, BC AD, and IY because it rhymes. So you're going to have a white precipitate, a cream precipitate, or a yellow precipitate. Name and formula, obviously you've got silver chloride, silver bromide, silver iodide, and you've got silver is a 1+ ion, and obviously your halides are 1-, so very straightforward formulas there. So you then, following that, you add some, in the first instance, dilute. So 1, you add dilute, 2, you add concentrated ammonia. Now you could also be asked the reason for this step, and you could be forgiven for writing to see if it dissolves, and yes, that is why you add it. But the point is, what's the necessity of that? If we've already said, well, that's white, that's cream, and that's yellow, so I know what I've got, then what's the point in doing this step? Well, the point is that actually these are all quite similar colours. White and cream could be mistaken for each other. Cream and yellow potentially could be mistaken for each other. White and yellow perhaps not so much, but there are, you know, they're similar. It's a subjective test. So that's the reason for this second part. So what you should find is that when you add dilute ammonia to your silver chloride, it will dissolve. So I'm going to put here, dissolves in dilute. Silver bromide will not dissolve in dilute ammonia, so I'll put no, dilute, yes, conc. It will dissolve in concentrated ammonia. And iodide will not dissolve at all. Okay, so in terms of the trend of the solubility, as you go down the group, again this is halides, not halogens, there is decreasing solubility. Okay. Right, that is as much as I'm going to say on that. I'd like to turn to part 2 of this practical, which is the reactions of the halide ions, specifically it's the sodium halide ions, with concentrated sulfuric acid. Now, the results table here prompts you to write which gases you observe, or if you observe a gas, the colour of that gas, perhaps the contents of the test tube, and this is observation, so it's just asking for colours basically, or if there's any precipitates or anything like that. Then the name of the products, and from that deducing the trend in the reducing ability of the halide ions. So we'll come back to that in a bit, but let's just have a look for now at the reactions of the sodium halides. And we only look here at sodium chloride, sodium bromide, and sodium iodide. Now, as we go down our halide group, so if I just put that up here, as we go down that group, their reducing ability increases. So as you go down, increasing, reducing ability, which makes sense. Remember, if something is a reducing agent, then it itself is oxidized, so it is losing electrons and giving them to something else, thereby reducing that something else. Now, as you go down the group, it becomes easier for our halides to lose electrons because they're bigger. There's a larger atomic radius, therefore weaker forces of electrostatic attraction between the nucleus and that valence electron. And so therefore, as you go down the group, they become stronger reducing agents. Now, fluoride we don't look at because it basically doesn't do it very well at all. But our chloride ions will reduce ever so slightly, a little bit. They're not brilliant. Bromide ions will reduce, and iodide ions will definitely reduce. And we look at their reaction with H2SO4, sulfuric acid, as evidence of that. Now, it sounds kind of silly to say, but sulfuric acid will react in two ways. Way one is as an acid, which sounds obvious because it is an acid, therefore it will react as an acid. But what that means is it will act as a proton donor. Okay, and it will donate a proton to your halide ion, and it will give you, if it was sodium chloride, you'll get the hydrogen chloride gas, or hydrogen bromide gas, or hydrogen iodide gas. The second way it can react is as an oxidizing agent, and when you do unit 7 you look at some common oxidizing and reducing agents, and H2SO4 features as one of those common oxidizing agents, and we're going to see now how that is the case. So first of all then, the reaction of sodium chloride with sulfuric acid. Now, our chloride ions are not strong enough reducing agents to reduce the sulfuric acid. And so with sodium chloride, the only reaction you will get is sulfuric acid acting as an acid, and you will produce HCl gas. That is not hydrochloric acid, that is hydrogen chloride gas. Okay, and then left over you've got sodium, and you've got one hydrogen, and you've got SO4, so you will also get NaHSO4. Now, you will always get that with any of these sodium halides. The only thing that differs is the hydrogen halide gas that you get. So this will give you, you'll have the same reaction for all three, you just need to change that for either Br or I, and therefore you change that either to Br or I, and they are all gases. And all of them, and I'm just going to stick with HCl here, HCl gas will react with ammonia gas to give the ammonium salt. That is a white solid, and you will get white fumes produced. Okay, so the observations that you will see are white fumes, hydrogen chloride gas. It will react with ammonia to give you the ammonium salt, NH4Cl or NH4Br or NH4I, and that is a white solid. Now, in the case of sodium chloride, that is where the reaction stops. Okay, it won't react any further, and so if all you observe is a white solid and some white fumes and nothing else, then you know the particular sodium halide you had was sodium chloride. Okay, I'm going to stop this video there, partly because my husband has to go to work now, and in the second one I will do the reactions of sodium bromide and sodium iodide. Okay.